Hi everyone, welcome back to Math 112. This is Scott. Let's get started. Today, what we are going to be doing is talking about section 5.6, in which we will introduce one last form of function transformation, namely horizontal shift, which in the case of these sinusoidal functions, sines and cosines, we frequently will call the phase shift. Okay. So the idea here is that we are introducing a horizontal shift that will then change the graph by moving all of the key points some designated horizontal amount. So horizontal shift, aka this is also known as the phase shift. Alright, so the way this works, there are two formats. And we're just going to focus on using sine here, rather than listing all the formats for all of the trigonometric functions. So the two main formats would be like this, where y is equal to a sine omega x. So far nothing is different here, but now here comes the difference. Minus phi for phase, plus b. Or the other version of this would be writing it with the omega factored out from inside those parentheses. Which would then just make it a naked x there, and that will make this phi over omega, and then that plus b. Okay, so in this setup, and actually here, let me point out what just happened here. We factor out the omega, which is the coefficient of x. So it's the coefficient of x that we factored out to produce this. So in this setup, phi over omega represents the horizontal shift of the function. Everything else about this still has the same meaning that the function had from the very beginning. So the a will still do the same thing as far as the vertical stretch. So that would mean it's going to give us the amplitude once we take the absolute value. The b is still going to give us the midline, and we'll still use omega to get the period. So using this, so we can still find the key points as before, and we can just shift them all. So shift all the key points phi over omega units to the right. And one thing to notice here, so one thing to note, phi or phi over omega is being subtracted. So that's important to note. Okay, let's just launch into this, give it a try. So as an example, for all of these, identify the period, midline, amplitude, phi, phase shift, and key points of the function, and then sketch a graph. Okay, so let's just bite this off and see what we can produce here. So, as an example, first let's just take something like this. Y equals -2 sine 3x plus, let's say, plus pi over 2 plus 1. Okay. So first things first. Let's just identify what's playing the role of what. So A here is -2. And that means that the amplitude, which is never negative, will be the absolute value of that, be 2. Okay, what's playing the role of the omega? The omega here is 3, so it's the coefficient on the x, and then that implies that the period is 2 pi over 3. Remember, for sines and cosines, it's 2 pi divided by the omega, which means that the key points will be so they're going to be 1/4 times 2 pi over 3, which is going to equal, if we cancel a common factor there, that's going to be a 2, 1, it's just going to be a pi over 6. So the key points are going to be happening every pi over 6. The fact that this is a negative sign, that implies that it starts, quote unquote, starts at at mid, going down. Now, the phase shift, actually I start with the phi. So phi is equal to, now at first, you might be tempted to say pi over 2, but be careful. If you look back at the formula, in this format, it's whatever, so it's subtracting phi, which means that phi is the opposite of whatever it looks like it is. So it's negative pi over 2, which means that the phase shift is going to be phi over omega, which is negative pi over 2 over 3, which is equal to negative pi over 2 times 1/3, which is equal to negative pi over 6. So that means that because this is negative, it's going to the left. So shift the graph left by pi over 6. Units. So this takes some getting used to, and the reason for that is horizontal shifts. They always happen in a sort of counterintuitive fashion. Horizontally, when you want it to move to the right, you have to subtract. If you want to move it to the left, you have to add. That's why adding the pi over 2 moves it to the left. And then as far as like how far it moves the graph, that requires rewriting it as phi over omega. So then, if we rewrite it using the other format, we'll have y equals negative 2 sine, and this is just what happens when you factor out the omega. We're going to have 3 times x plus pi over 6, all plus 1. Oh, I didn't say the midline yet. So the midline is at 1. Okay. So this means that the key points. So the key points will be starting. So the start will be negative pi over 6. So start here, and then it will just go up by pi over 6 each time. So that'll be plus pi over 6, which will be, so that's plus pi over 6 each time. That's what's going on here. So then that's gonna, so from a starting point of that, the next one will be 0, then it'll be positive pi over 6. And so this will be mid, min, mid, then add another pi over 6, so it'd be 2 pi over 6, which we can reduce to be pi over 3. And that will be max. And then finally add one more pi over 6, so that'll be 3 pi over 6, which is the same as pi over 2. And that will be at the mid again, ready to start all over again. Okay, so now we've got the information that we need in order to produce the graph here. The important thing to note is the period is 2 pi over 3, or in other words, 4 pi over 6, just for the record. So it's going to be negative pi over 6 is important to us, positive pi over 6, 2 pi over 6, in other words, pi over 3, 3 pi over 6, in other words, pi over 2, 4 pi over 6, in other words, 2 pi over 3. So with fractions, it can be a little bit helter-skelter as far as the denominators. If you look at them, it can be a little hard to see, but really, if you wanted to think about this as just being 2 pi over 6, 3 pi over 6, 4 pi over 6, that would be a perfectly reasonable way to express it as well. Alright, other stuff that we need to know. So there's a midline at y equals 1. We will often graph at least 2 periods, but basically once you've got 1 period, you've got the whole story. That's the whole point of periodic functions. Okay, now the amplitude is 2, which means it goes up 2 units and down 2 units from that midline. So that would put us at a maximum of 3 A minimum of -1 in the midline is, of course, +1. So this is the starting point. Now, periodic functions don't actually start anywhere. They go infinitely far in every direction. It's just the start, as in where we will be beginning the sequence of key points for our purposes. What's going on here? Did I miss one here? Oh, that's right. So I went a little bit more than a period here. Sorry, so it should be going down to there. Okay, so then what's this going to look like? Down, up, down, and technically, of course, it is periodic, so it would continue its journey up and down and up and down. So it did whatever normal negative sign would do. It just did it all pi/6 units to the left of where we were expecting it to be. Now, let's just try that one more time, one more function, and see what other things can happen here. So let's say y equals 2 cosine 4x minus 1. And I won't bother with a midline here. So 2 times cosine 4x minus 1. So this is not different just because it's cosine. We just know that cosine has a different starting behavior. Other than that, our approach is completely the same. So let's figure out what's going on here. So a equals 2, which means that the amplitude is again 2. The other stuff, the omega here is 4. It's the coefficient on the x, which means that the period is equal to 2 pi over 4, which is equal to just pi over 2. And then that means that the key points are going to be every period times 1/4. So 1/4 times pi over 2 is pi over 8. Okay, what else do we know? We have a positive cosine, which implies that we are starting at the maximum. So cosine starts at the maximum. If it's negative cosine, it starts at the minimum. All right, what else we have? Phi is equal to 1. So that's the number being subtracted there. It's in the right format already, which implies that the phase shift is phi divided by omega. So that's 1/4. Okay, so what that means is that that we shift the whole graph to the right by 1/4. Okay. Now that actually is a little bit awkward because it's not actually exactly consistent with our key points. And so when we do this, we may sometimes wish to switch over to decimals in order to make it a little bit easier to work with. Okay, so now if we rewrite the function according to the format with the omega factored out, this is what we would be looking at, and then we can figure out what's going to be going on with the key points. So the key points, so that they're going to start at 1/4, which I'm just going to write as 0.25. And then the next one, so each time we're going to be adding pi over 8. Now it's going to be pi over 8 plus 1/4. So since again, those one of them has a pi, one of them doesn't, it doesn't really make a whole lot of sense to try to write it precisely. So what I can just do is I can just I'll just break the decimal barrier and figure out what this is approximately and use that. So I'm going to say, oops, 0.3927 if I round it. Okay, so that's what I'll be adding each time to get my new x values. So 0.25 plus that, so plus 0.25 is going to be 0.66427. Then the next one, add 0.3927 to that. And that's going to be 1.0354, if I round it. And then what? So then the next one, here would be that plus again, 0.3927. So that's going to be 1.4281. Again, if I round it. So that's 1, 2, that's a start, and then we've gone 3/4 cycles in, so then the last one will be that, plus 0.3927 again, and that's going to be 1.8208. So again, I just used my calculator, I just added 0.3927 a bunch of times and got these numbers. Now thinking about this, it is a cosine, so that means the maximum will be where it starts, then it'll be at the midline, then it'll be at the minimum, then it'll be at the midline again, and it will finish by being at the maximum again. Okay, so that's where we are on our graph. So we have to, so when it comes to plotting this all out, the important thing is that we do use a nice consistent spacing for everything. So thinking about how this is going to go, let's just, so I'm just going to put, I guess, so we have a maximum here of 1.82, so let's just say 2, 1, 0.5, 1.5, and then the quarters right there. Okay, so how is this all going to be starting? It will be starting at its maximum, which will be 2, and the minimum that it will ever reach will be -2. The midline here was 0, the amplitude is 2. So this is where we will find ourselves at the start. And again, periodic functions don't technically start anywhere, but that's where we are starting our sequence of key points. Okay, now for the midline. So for the midline, so it will be hitting that at 0.6427, so it's about 2/3, so it will be about 0.75. So let's just say it'd be around here, roughly. Okay, and then it'll be at the minimum just barely after 1, so just slightly after 1. Then just a little bit before 1.5, it will be going through the midline again, and then it'll be at the maximum 0.82, so let's say right there. So something like that. I've given myself some very luxurious spacing here, but there is one cycle. And of course, like I said, there's no such thing as the start or the end of these things. They do continue to go up and go down and go up and go down for all eternity. So when we say start, we just mean a key point. That's where the key point sequence will begin as far as our purposes go. All right. Now, one of the main uses of these phase shifts would be what is called sinusoidal curve fitting. And the idea here is use some given data to put together a function in the form f of x equals, again, a, we'll just say by default sine omega x minus phi plus b. And now useful facts. Useful facts. All right, so first off, if we want the amplitude is equal to, well, one way of doing it is max minus the midline, but we're not going to always be given the midline here. So maybe we'll be given the max and the min. So max minus min gives you the width all the way from the top to the bottom. Divide that by 2, and that'll be the amplitude. So that's a useful fact. Another useful fact is that sine, so positive sine, starts at mid going up. And so we need to put in a phase shift if we want to change that. Other useful facts would be the midline. Maybe we are not told what the midline is going to be, but we're told the max and the min, so how can we figure out the midline from that? Well, it'd be the average of the two. That's what's right in between. So max plus min divided by 2. Okay, I guess this will pretty much have to do it for now. Oh, and I guess we should also note that the max happens only once per period, but the midline happens twice per period, once on the way up, once on the way down. The max slash min happens once per period, but the mid happens twice. This is just an easy mistake to make sometimes, is to accidentally not take proper account of that fact. All right. Well, enough of that. Let's just try to get this, put this into play. Use this in an example. And one of the classic examples that we will see will be tides. So let me find here a good piece of information. All right, so example. The tides are on a 12.5 hour cycle. let's say a high tide of, let's just say 6 feet happens at 1:37 a.m. The low tide is, let's just say, -1 foot. So the water surges up 6 feet, down 1 foot at low tide from baseline. All right, now this is actually enough information for us to start sketching things out. So first question. So question number, so A. When is the next high tide? Well, that actually is just asking us to figure out in time, in terms of the time, what will be 12.5 hours after this time. So the easiest way to deal with these kinds of questions usually is going to be to just change them into some sort of a common framework, either all into decimals or all into minutes and seconds and such. And also use a 24-hour clock, not AM and PM. So 1:37 AM. So that we can just call, so we'll just set the clock as midnight equals 0, and then this would be 1 point, and here, sorry, 1:37, and here you would figure this out the same way you would do it if it was minutes of degree. So 37 divided by 60, 1.6166666. So we'll call that x equals 1.616666. Okay, so we know that the tides are on a 12.5-hour cycle. A high tide is a maximum, and so we know the next max will come 12.5 hours later. So x plus, sorry, so 1.61666666 plus 12.5, that's going to equal 13.16, whatever, I believe. Here, let's not be too cocky here. We'll just try. Don't be a hero on your calculations. 14. Yep, that's why. I did the hard part, the decimals, but I messed up the easy part, the numbers. Okay. Now, what would that actually be as far as what time? So this means, so the 14 on a 12-hour clock would be 2 p.m. plus, and then 0.116666 times 60. So it's the same way again you would do it if these were like degrees. So then here, the easiest way to do that without having to type it all would be subtract the 26. Sorry, what am I doing? Subtract the 14, I mean. What am I? My calculator, it just got messed up. All right, so okay, so if I do the 0.1166666666 times 60, that's going to give me I did divided by all kinds of typos happening. All right, here we go. So it's going to equal, it looks like 7. So we'd round that to 7. And so it's 2, together it's 2:07 p.m. would be us putting the pieces of information together. Which actually, come to think of it, makes perfect sense. It's 12 hours and 30 minutes, 1 hour, or 1:37, so that all adds up. Okay, now that would just be a piece of information that didn't require us to do any sinusoidal anything, really. I was just trying to add numbers that are given in minutes with other numbers that are given in decimals. Now, find a formula. F of x equals a, so they're here telling us the formula, or the format of the formula that they want from us. Sine, omega x minus phi plus b. Okay, so let's just see what we've got here. Information that we are told. So the information that we are told is the max equals 6, the min equals -1. So from that we can figure out, for one thing, the amplitude. So that's 6 minus -1 divided by 2, which would be 7 divided by 2, which is 3.5. Okay, so the amplitude is 3.5. Now we know that there is so it's at the maximum at x equals 1.61666666. So that means a quarter cycle before that, it must have been at its midline, which is the usual starting place for sine. So that means the starting value. So the start is 1/4 period before that. And t, we are told, is 12.5, which implies that the quarter period would be 12.5 divided by 4, which would be 3.125, I believe. Yep, 3.125. Okay, so that means that our starting point so the start then would be 1.616666 minus 3.125, which is going to equal, so that's the starting value, so that means that that's going to equal, so 1.61666666 minus answer is -1.508333333. Okay, so that represents then the phase shift. So that's the phase shift, which in turn means that phi over omega equals that. So that means that phi itself would equal -1.5083333 times omega Oh, and since the period is equal to 12.5, that means, sorry, the period is 12.5. That means that omega is going to be 2 pi divided by that. So that's going to be times. And just a note in your or in the homework, the Pearson MyLab portal, it's going to want these to be in fractions, and so it won't accept it if it has a decimal in it. So you can multiply the top and bottom by 2 in order to clear that away. Kind of a strange thing, but for some reason it wants your omega to be in a pure fraction, no decimal. Okay, so there's that. And then this is times 4 pi over 25, which will then equal negative 758. 2. So I believe it wants you to round this particular thing to 4 decimal places. Okay, so then that gives us altogether our formula. So our formula then wait, we didn't find the midline yet. So midline. So that's that's equal to the max plus the min divided by 2. So that's 6 plus negative 1 divided by 2. So that's going to be 5 over 2, or 2.5. So then the formula. So now we've got all the pieces. So the amplitude here is just going to be the same as the A, because we've adjusted the phase shift in order to start our careers at the midline. So 3.5 sine 4 pi over 25 x minus a negative 7582 plus 2.5. So in other words, plus. .5 sine 4 pi over 25 plus 0.7582 plus 2.5. And then the final question that could lead to is use the formula to predict the tide height at noon. And that would be x equals 12. Okay, so what that means then is just plug into the formula that value for x. And here, we can just do that in a calculator. And the important thing is just make sure your calculator is in a suitable mode. So this one is currently in degrees, which these formulas, you can tell by the pi, are always going to require radians. So always radians. So So let's see, use radians. It's always radians mode, and that's because of the 2 pi that we are using for the omega calculation. Okay, so now the way this works is you just, once it's in radians, you can just enter it, 3.5 sine, and you just put in all the pieces that you want. So what do I have? 4 pi divided by 25 times x, which is 12, minus negative, so I guess plus, what is it? 0.7582. And the parentheses for the sine, plus 2.5. Okay, so this is us just entering that formula with a 12 for the x. So we made a formula, and now we use the formula to predict a height, and it says that it would be at 4.199. So So 4.199, and I round it to 4 decimal places, 1 feet. So that would be how you would make a formula, how you would use a formula, and then let's do a quick reality check here. So we have a high tide at 2:07. We know the high tide is at 6 feet. This is a little bit before that, so it's not going to quite be at the high tide yet. Does that all make sense? Seems fine to me. So that's how that would go. Now, the last example of these types of things that we have to do would be that involve the length of the day. So, as you've all noticed, during the winter the days shorten and the nights lengthen, and during the summer it's the opposite. And here are some assorted facts that you'll find useful whenever you're doing any of the sorts of problems that will pertain to the length of the day. So, longest day. So this is the summer solstice. Most years that would occur on June 21st or 22nd, depending, and it is the 172nd day. So that's a fact that we will just use. This happened to have been the case in 2017, which is when your book's examples are all drawn from. So the shortest day, on the other hand, that would be the winter solstice. And that is on the 355th day of the year. Okay, so these are just two facts that will come in handy for all kinds of different things. All right, now, for our example, let's just take the city of Boston. Boston. So we're just going to look at some hours of sunlight in Boston. So on the summer solstice, the length of the day, meaning daylight, is 15.28 hours. On the winter solstice, the length of the day is, what's it say here, 9.07 hours. All right, now find a formula for the length of day, and the format of the formula is going to be f of x equals a sine omega x minus phi plus b. So regular format. And use it to determine the length of the day, say April 1st, which is day number 91, the 91st. The 91st day. Okay, so let's try to figure out what we have been told and what we can get from it. So we know already that the max is 15.28 and that the min is 9.07. So from that we can figure out quickly the midline and amplitude. So let's start with the amplitude. So the amplitude is max minus min divided by 2. And a quick calculation will tell us 15.28 minus 9.07. Enter. 15.28 minus 9.07. Enter. And then divide by 2. Rather than using parentheses, I just did it in 2 steps. So it's 3.105. Okay, that is the amplitude. The midline. So that's going to be 15.28 plus 9.07, all divided by 2. Which is going to equal 12.175. Okay, now let's think. Also, the period is 365, which implies that omega, which is 2 pi over the period, is 2 pi over 365. We can just leave it like that. Okay, that's a lot of it. What do we still need? We still need the phase shift, and then from that we can get the phi. Okay, so let's see. So it starts. So it starts 1/4 period before the max. So let's just figure out what that is. So 1/4 t is going to be 2 pi 365 times 1/4, and so that's going to be if they're going to like it to be a fraction. Oh, sorry, that's omega. That's not the period. So the T is 365, so that's going to be 365 over 4, which here it'd be better to just get that as a decimal, which is 91.25. Okay, so that means that the phase shift. So it's going to be 172. This is for the x value of the max. Minus that 91.25, and that's the 1/4 period. And so it's going to be 172 minus 91.25. It's going to be 80.75. It's just me calculating what I said. Okay, now that then means that 80.75, that's the horizontal shift. So that's equal to phi over omega. Now omega we found was 2 pi over 365. So phi will be equal to 80.75 times omega, which would be approximately equal to, so 80.75 times 2 pi divided by 365, which is 1.3900. Okay, so then the formula. The formula here, we've got all the pieces that we need. We have the amplitude, and because of the way we did the phase shift, that means we're going to be talking about a positive sign. So f of x is equal to, the amplitude was 3.105, sine, we have the omega, it's 2 pi over 365, times x, minus, now the phi, which is 1.3900, and then all plus the midline, which is the 12.175. And then the actual question was asking the 91st day of the year, what the length of the day would be. So f of 91 would equal, and then we can just calculate away. So we'll just calculate this whole thing as it is. So I'm just going to put it all in here. 3.105 sine, and it starts the parentheses for me, 2 pi divided by 365 times 91 minus 1.3, 91 minus 1.3900 plus 12.175. Okay, quick check. Looks good. So quick, and then I hit enter, and I get 12.72 hours. So I get 12.72 72 hours on April 1st. Now, quick reality check. Does this make sense? Well, April 1st is pretty close actually to the spring equinox. So the spring equinox happens in late March, so about a week before April 1st. And sure enough, that's when the length of the day is at the midline, which would be very close to 12 hours. And so here, this is a very, very reasonable amount of time for the day to be April 1st. So our formula seems to pass a reality check. Okay, steps. The steps that we went through. So we had to use the maximum and the minimum to find the amplitude and the midline. We were told what the period would be, or here we just knew the period would be 1 year. And then from the period, you can find the omega. And then the only hard part left is that you're not usually going to be told very directly what to use as the phase shift. And so we have to throw some pieces together and hope for the best. So we found the phase shift by figuring out that we had to shift it to start 1/4 period before its maximum. And that's because we were talking about a sine and we want it to be starting right before it hits its maximum. And so we figured out what the phase shift would be, and then we solved for the phi, and then we had our formula. And that's how we did that. All right, I just wanted to quickly show everyone a little bit of what the homework is like for this section, just because it's a little bit strange and just requires you to know what it is they want from you. So the very first part of the homework is just giving you one of these trigonometric functions that has a horizontal shift attached to it. And so we just have to figure out the things that are relevant here. So for the amplitude, we can easily get that. It's just the coefficient in front of the sign. And the only thing that we might have to do is take the absolute value. If it should happen to be negative, we don't say the amplitude is negative. Okay, so what's the amplitude? This one's not so hard. We can do that. What is the period? Now, for the period, we need to figure out some of the other important things here. So the omega, in this case, would be 4. And so then that means that the period is 2 pi over 4. And then it says type an exact answer using pi as needed. Use integers or fractions for any number. So in other words, no decimals. So we would simplify this a little bit and make it pi over 2. Okay, what next? Now, the phase shift. So not the phi, which is pi, but the phase shift. So phi is pi, and the phase shift is pi over omega. And notice this is a minus pi, which means the phase shift is pi. Or sorry, the phi is pi. So okay, this is going to be pi over omega, so pi over 4. And if it had been plus pi up in the original formula, then this would have been negative pi over 4. Okay. Now we need to actually graph this. So what we're going to use is all of those pieces, and then what we need to do is use the graphing tools that we typically have to work with here. Now the tool that is going to here be of use to us is the sine tool. So there's the sine tool or the cosine tool. We'll use the sine tool because that's the function that we're talking about here. And now you just have to click on the graph, and then it starts putting your pieces into play. We need the amplitude to be 3. It's currently 1, 2, 3. All right. Vertical shift. No vertical shift here. Now the period was supposed to be not 2 pi, but pi over 2. And there's that. And now the phase shift was pi over 4. And we can just actually enter that literally in here, pi over 4. We don't have to evaluate it or anything. So enter. All right, is this how we wanted it? Looks pretty good to me. So we'll save it and we'll check. All right, so that's how you do this sort of thing. Now this next one, very similar. Here, this is one where it has the somewhat awkward thing where our phase shift is not going to be compatible with our actual period. So here, let's just figure this out. So parts of this are very easy. So the A is 3, and since it's positive, we don't have to worry about it. The midline we can see is -4. We can see that the omega is pi. So the omega is pi, and now the phi is the part that's being subtracted from the x term. And so that's going to be actually -2, which means that phi over omega, the phase shift, will be -2 over pi. So that's a little bit awkward. It's an awkward number, 2 over pi. Pi over 2, we see that kind of thing all the time. 2 over pi, much less common. All right, 3. So 3, the period. Oh, we didn't calculate the period yet. The period was 2 pi over omega, which is 2 pi over pi, which is equal to just 2. Okay. Now phase shift. So it says type an exact answer using pi as needed. So we're not evaluating this into decimals, which if we were doing this by hand, we would need to, because otherwise it doesn't really, we don't really know how far -2 over pi would be to actually do the shift. So there's that, and then so it says for any boxes shown with a grapher, type an exact answer, etc. What do we have here again? It's a sine. So click the graph. Let me clear my stuff here. Okay, amplitude. So the amplitude was 3, just like before. The period was just 2. Oops. Thing. Okay, vertical shift. Looks like we want -4. Phase shift. We want -2 over pi. So there's our graph, and I will check. All right, so that's how those go. Now, similar. Now here, so here what we have are other questions of the same sort. It's just these happen to be tied into a word problem. It's not fundamentally any different though. But now we have like the hours. We have the tide and hours situation. So what have we got here? We've got some information about about a tide, and we are told some of the important things here. So the max is 8.6. The min was negative 0.8. Good to know. Use the given time between consecutive high tides. So time between consecutive high tides is the same as the period actually, which is 12.5. So there's that. And then it says use the time between consecutive high tides to approximate when the next tide will occur. And by that they mean high tide. So let's see, this is the max at x equals 3.1, or 6167. So they went ahead and translated it from a hour-minute thing into a decimal for us. And while we're at it, the minimum happened at, they told us this, they didn't actually technically need to, but I'm not complaining. Okay, now the next high tide. So that's going to be 3.6167 plus 12.5. And then that's just going to equal whatever it equals. I'm just going to put it into a calculator. 3.6167 plus 12.5 is equal to 16.1167. Now that is so that one is not set to proper format yet. So first off, in a 12-hour clock, 16 would correspond to 4 p.m. plus, and we can convert the decimal into minutes the same way we would if it were an angle in degrees. So that's sorry, hold on. So that is 0.1167 times 60 is equal to 7.002. And so this is going to be 4:07 p.m. And notice they've, for some reason, already given us the PM and the 0. I don't know why they gave us the O, but they did. So there's that. Now find a sinusoidal function, and then the way they want us to do this is to just list out the A, the B, the omega, and the phi. Okay, well, to find the A, we would just use the max and the min. So it's max minus min divided by 2. So it's, in other words, plus 0.8. So let me see here. So it's going to be 8.6 plus 0.8 equals 9.4 divided by 2, 4.7. So that actually is already now the answer to the question of A, because we're going to be doing our shift so that we never need to use a negative value here. It says an integer or decimal. So there it is. The omega. So to find the omega, we just need to use the period. So omega is equal to 2 pi over the period. Sorry, it's 2 pi over 12.5, I mean. Now here, let me show you. This is kind of silly. Your homework portal here won't let you enter it in that form. I'll show you why. So 2 pi divided by 12.5. So it says type an exact answer in terms of pi, use integers or fractions. So unfortunately, this is not a fraction and it's not an integer, so it's not happy. It says, although it's equal to the correct answer, it's not in the correct form. So what they actually want us to do here is to simplify this fraction a little bit. And the way we'll do that is we'll multiply the top and bottom by 2 so that it no longer has a decimal in it. So this is not something that we would usually want to do, but the computer basically makes us here. So 4 pi over 25 would be the simplified version of this, just as it was in our other example. So 4 pi over 25. So that's what they want from us here. And then for the phi, we don't know the phi yet, actually. We have to work our way to it. So the phase shift. So we start by figuring out the phase shift. So it's going to be a quarter period before the max. This will pretty much always be our approach. So that's going to be 12.5 divided by 4 before the 3.6167. So that's going to, so 3.6167, minus 3.125. That's the 12.5 over 4. And that's going to equal according to my calculations, 0.4917. So this is the phase shift. But that's not the phi. The phi is actually omega times the phase shift. So phi divided by omega, that's what's equal to the 0.4917. And so that means that phi is equal to 0.4917 times omega, which then is 0.4917 times 2 pi. Sorry, times 4 pi over 25. Which we can just calculate right now. Using just a calculator, just enter it basically as it is. 0.4917 times 4 pi divided by 25. So what does it say? Round to 4 decimal places as needed. So this is 0.2472. If I round it to the 4 decimal places. Okay, and now let's see. 2.472. Okay. The B, we didn't find that yet. The midline. So the midline we will get by doing the average. So the midline is equal to 8.6 plus negative 0.8 over 2. So halfway between the max and the min is where you'll find the midline. And so here, that's going to be 8.6 minus 0.8 divided by 2. 3.9. Okay. Now, this use the function in part B to predict the height of the water at the next high tide. This question is similar to what we did, but actually a lot easier because we don't actually really need to use our function to predict the height of the water at the next high tide. This is a periodic function. Periodic functions repeat their values. And so I actually know that the next high tide will be the same height as the previous one. If they'd given me a specific time and asked what the height would be, height of the water, then I would have to plug that into the formula. But the previous high tide will be the same as the next high tide, 8.6. So we're assuming these are purely periodic, which is not necessarily the case for actual tides. They are not always exactly the same amount each time, but that's the assumption that we're going to make here. Okay, so here what we have is a similar question to that Boston business. And so the way we would go about it is use the max and the min to find the A and the B, and then use the shift and the period to find the omega and the phi, and then you would just proceed. It would go very much like the example that we did. So you would just do a very similar thing here. I'm not going to go through the exact same steps again. It would be very, very similar. But those are the questions that you have to deal with on your homework. And the hardest thing to deal with will be what the MyLab wants from you in the form of your numbers. So be careful. Be careful that you obey any specific instructions as to fractions, integers, etc. Okay, so let's go ahead and stop it there. So that's going to do it for section 5.6. Thank you for joining me, and I'll see you next time. Till then, bye.